All right, we're going to look at number 3 from the homework, and it wants us to find the domain of the following functions. So if you think about all of our parent functions, the domain for all of them has been negative infinity to infinity, except for 2 cases, and that's when we have our square root function and our reciprocal function. And the reason why those ones have an exception is because we can't plug in any real number, which is what negative infinity to infinity means. For square root functions, remember that we want to have the inside part greater than or equal to 0. For our reciprocal function, we do not want the denominator to be 0. So what would probably be finding out is, well, when does it equal 0? We don't want that to happen. Okay. So knowing that fractions, we don't want a 0 in the denominator, that's a big no, and we don't want negative stuff under the square root. That will change what our domains are. So our very first function that we have up here, f of t equals t minus 4, that's just a nice linear function, so that's going to be all real numbers for the domain, or you can write that as negative infinity to infinity, which is what it said to write in interval notation. All right, for part 2 here, g of t equals the square root of t minus 4. Well, we've been working on our transformations. You could think of the graph of that function, which is being shifted to the right 4 spaces. But we can also think about that inside part. We want to make sure that it's greater than or equal to 0. It has to be positive. We can solve this inequality. Add 4, add 4. We get t is greater than or equal to 4. And so with interval notation, that means 4 all the way to infinity, and we will include 4 because that makes it 0, which 0 is okay under that square root. For h of t, it's very similar, but they kind of interchange that 4 and t. And so if you take a look at that, if we look at 4 minus t, we want that to be greater than or equal to 0. There's a couple different ways that you can kind of solve this for t. If I try and move the t over, I'm going to get 4 is greater than or equal to t. But really that just means that t is less than or equal to 4. So just kind of rewriting that with the t first. Notice that the inequality is pointing to the t, letting us know that t is less. So we have t is less than or equal to 4. So that's going to be everything smaller than 4. That goes all the way to negative infinity up until 4, including it. All right, for the k of t function, that one, it actually has a fraction, but if you look at the denominator, the fraction looks just like what we just were working on. So we have 2 things we want here. We don't want the denominator equal to 0. We already said that's a big no. And we also want to make sure under the square root is positive. So we know that the values negative infinity to 4 make us greater than or equal to 0, and the 4 makes 0. And you could double check that. Square root of 4 minus t, like when does that equal 0? If you think about it, it's only going to be when t equals 4. So we don't want that. And so since we don't want that, it's going to be the same interval that we got on the last part, but we're going to have it negative infinity to 4 with a parenthesis. Okay, we wanted to know, again, when it was equal to 0, because that's where we're undefined. So that's why we didn't want to use the number 4. All right. For the m of t equals t plus 6 over t minus 4, there's no square roots to worry about, so all we're concerned with is what makes the bottom 0. When is t minus 4 equal to 0? Because that's when we're going to be undefined. Add 4, that happens when t equals 4. So what we're saying then is that's the only number that we don't want. Okay, because that's where we're undefined here. So if you think about, we're normally negative infinity to infinity, but we're saying except for 4. So the way that we write that, and you can imagine it on a number line if that's helpful, number line goes negative infinity to infinity. So we're saying we cover up all of this except we don't want to include 4. So there's kind of 2 sections there. We have negative infinity to 4, and then we have 4 to infinity. Whenever you have 2 intervals like that, we put a little u in between. That's for union. It means either in that one or in that one. So we have that one or that one. All right, for the last question there, if we look at the denominator and we're trying to see, well, when does t squared minus 4 equal 0? Well, we could think about that a couple different ways. I know just by looking at it that a 2 would be like a bad number because 2 squared is 4 and 4 minus 4 is 0. We can also solve it by factoring. This is the difference of 2 squares, so it factors to t plus 2, t minus 2 equal to 0. And there's a 0 product property that says t plus 2 equals 0 or t minus 2 equals 0. And so that's going to get us t equals negative 2 and t equals positive 2. And those, again, are things that we don't want because we're undefined there. So we want to be any number but those guys. So if I draw the number line again, and I say from negative infinity to infinity, we want to leave out negative 2 and 2. But we want to be everything else. This time we have 3 little intervals. We have negative infinity to negative 2. We have negative 2 to 2. And last 2 to infinity. Those are those 3 sections. So the first one, negative infinity to negative 2. Then we have negative 2 to 2. And lastly, 2 to infinity down below. And so we have those 3. I'll separate them with U's. So hope that makes a little more sense.